Hi, I'm ED-SKaR and I want to talk about MOSFETs because there's a lot of misinformation and a lot of confusion about what they are, how complicated they are, what they're for, and various other factors of it. Now, quite specifically today, I am not going to do any maths whatsoever. So if you're afraid of MOSFETs or the kind of complexity therein, this is the video for you. If I was a proper YouTuber, I'd have an introduction right here, but I'm not, so I don't. So what is a MOSFET? A metal oxide field effect transistor, of course, we all know that. But what's it actually for practically? Well, in terms of pretty much every application for Nerf and also Airsoft, it's a bypass for a switch. And the problem with that comes down to these little things. Now, this is one of the switches that Hasbro lovingly gives us in pretty much every electronic build that they release. And it is a very small and not particularly durable electric switch. And when us modders start putting proper motors and lipos and all of the rest of it, we increase the current of the circuit and the voltage of the circuit well beyond the capability of these little switches. And so the bits of metal inside get too hot and melt, or as we refer to it generally, they burn out. So these switches need to go, and they need to be replaced with something better. And the usual go-to is these kind of very clicky... Okay, I'll stop that. Switches. However, even ones this small, it's not necessarily all that easy to fit them in. And in some cases, particularly with like 2- and 3-stage builds that are starting to become more popular now, switches like this don't have quite enough capability to run the amps that are going to be drawn in those systems. So that's where the MOSFET steps in, because all a MOSFET really does in a Nerf gun or a Airsoft gun or anything like that, it acts as a switch bypass. And by bypass, what I mean is that instead of having a single circuit, motor, battery, switch, you have 2 circuits. And the first main circuit is motor, battery, and the MOSFET, which is acting as your switch in that circuit. But then you have a secondary circuit that just goes from the MOSFET to the switch. And what it means is that the full voltage and the full current from the battery to the motors and only goes through the MOSFET. And the switch is on a low power line, usually, depending on what MOSFET you're using, it's usually a 5-volt circuit. Sometimes it's half the voltage of the main system. But as I said, there's quite a few different ways that they work. Instead of removing the original Hasbro switch and hacking up the shell to fit something that's kind of 6-7 times larger physically, you can just maintain this switch because you're not running high voltage or high current through it. Although if you still like the... Okay, I'll stop that. If you still like the clicky, you can of course use one of these switches with a MOSFET as well. It's just not required from an electrical point of view, but it does give you the nice kind of tactile click, which is quite satisfying. Then comes the point of expense, because pre-built MOSFETs, particularly Airsoft ones, like the Gate Pico SSR, which has been my favourite for quite some time, and I've got one from Ace, which I've used once before. Both of these two come between £15 and £20 for a circuit board, and that's rather a lot. And that's where UKNerfWar pops in, because they have, in this handy brown paper bag, a kit to actually build your own MOSFET. And this, instead of costing £15 to £20, costs £1. Proper cheap. It's just the basic components required to actually build the MOSFET and solder it all together for yourself. But isn't that terribly complicated to build a MOSFET? Well, firstly, they've done all of the maths for you, so you don't have to worry about that. And secondly, it is a grand total of 3 components. The base FET itself, a resistor, and a diode. How complicated can that be? Given the number of components in even a strife, well, this doesn't even double that. Switch, Dean's connector or XT60, and the pair of flywheels. So that's 4 components, whereas this is just 3, so it's not even doubling that. If you then add in something like a full auto kit where you've got another switch and another motor, well, this is half of the number of components. But this one has 3 pins, and that's terribly complicated, isn't it, instead of just 2? Well, again, that's not particularly difficult because we wire up a flywheel cage in an odd way. You've got two motors and each has two contacts, so you've got four contacts to solder, but then we end up with 6 or 8, depending on how you solder it together, because we're running them in parallel. And you have a bridge or a splice for possibly each. And of course, thank you very much to UKNerfWar for donating the MOSFET kit for me to have a look at on video.
So here is the circuit diagram for the MOSFET kit, and I want to point out that the diode here, the way that it's drawn is, I don't want to say wrong, but it's certainly misleading because of the way that diodes work. So I'm just going to quickly change that to make it very simple and easy for everyone to understand. I've drawn in the diode here with the silver line that's physically on the diode in place. So this is not the correct way to actually draw the circuit diagram, but it means it's very clear to everyone which way around it's supposed to go. Let's have a look at the circuit diagram and identify the mainline circuit and the control line. So from the battery, we go down this line to the motors, and we go from the motors into the MOSFET here, and we're going in on the middle pin of the MOSFET. We're coming out on the right-hand pin of the MOSFET, and then we're going back to the battery. So that's our main line. That's what sends the voltage and current from the battery to the motor and actually makes them spin. And let's find the control circuit. So from the left-hand pin on the MOSFET, we go through the switch and then into the positive line on the main circuit. And this is the physical switch that's in your Nerf shell. On a Strife, this is the switch that's underneath the rev button. But there's also the other two components, and the maths behind why they work and how they work isn't something I'm going to deal with today. But we've got a resistor here that just connects from the left to the right hand pin, so that's pretty simple. And we have the diode here that connects across the mainline positive and the mainline negative between the motor and the MOSFET. Now what I'm planning to do is I'm probably going to put this diode right up at this end inside the flywheel cage essentially, or you can put it further up with closer to where the battery compartment is, so long as the negative side of that is before the MOSFET. You cannot connect it across here, for example. So you could connect it from here to here, that would be fine. We can connect it here to here, that's fine, but you can't connect it in there. Right, so let's crack open a Strife and have a go.
Right, so first off, let's tin the connections on the FET itself. And let's get the resistor sorted as well. Okay, and let's let that cool down a bit before we go any further with the FET. And have a look on the inside of this. I have my other phone, and I'm going to make sure that I wire this up correctly. So from the motor, from the negative of the motor goes to the center pin. One thing to point out is that I would usually use a lighter to shrink the heat shrink. However, the FET itself is somewhat vulnerable, I think is the right term to use there, when it comes to heat, and they can get damaged at relatively low temperatures. So I want to make sure that the heat that I'm using to shrink the heat shrink doesn't damage the MOSFET while I'm working. So the next thing on my diagram is the negative line from the MOSFET to the battery now connects to the S. So hopefully this is clear enough, and what I'll show you, the metal kind of loop at the top is on the back of the FET. And actually if I show you the back, it's just this back plate essentially for the FET. And then part of the where the pins come out is slightly above that, and that means that this is the front and this is the back, which means that this pin is the S. So we've got the negative from the motors coming into the middle pin, and then from the S, the right hand pin, that goes to the negative to the motors. Okay, while I soldered that, the resistor popped off of the pin for the FET, but what's actually happened is all three pieces have joined together in the solder, so it's strong enough and I can carry on going. Okay, and there we have that. Right then, what's the next step? So the next step is we need one of the wires from the switch. Lines here are marked blue and red because the red joins up with the positive line, so that is a positive line when it's connected to that. Because it says NO and C on the switch, it doesn't actually matter which way around those go. The only thing that matters in this case is that when you pull the switch, it joins up the circuit, and when you let go of the switch, it disconnects it. So either one of the two wires from the switch goes to the G pin on the FET, and the other one goes into the positive line on the flywheel cage. Okay, so that's the FET itself all wired in and ready to go. I just need to put in the last component, the diode, and then of course I need to redo the XT60 connector. So what I'm planning to do with the diode here is actually hide it inside or kind of maybe even underneath the wiring of my flywheel cage. Just to connect this, the silver side of the diode goes to the positive line of the flywheel cage, and then the black side goes to the black again. And you can attach this up at the flywheel cage, or you can actually attach it into the main line closer to your the rest of the MOSFET circuitry. I think it's just easier to put it in down here. So I'm just going to pop this in. If you are going to do it up at the cage here, make absolutely certain that no part of any of these connections is touching any of the other connections or touching the cans on the motors, which they are not. So I can pop that back in. So there we go, that's all together now, and remember to always test with a nickel metal hydride or an alkaline or something like that. Something that's just got enough power to make the motors move. And then once you've tested it, you can then put in your LiPo. The song of its people. So how difficult was that really in comparison to wiring up a strife and putting in a big old switch down in the grip, which requires either epoxy or hot glue or a 3D printed component to hold the switch in place. There's quite a few more solder joints that you need to do, and you do need to be careful with the solder joints on the FET itself, because if you hold the soldering iron there for too long, you can end up overheating and burning out the FET before you've even had the chance to use it, and that's not great. That's why I found that tinning the three wires on the FET and then leaving it aside and going off to do some other part of the soldering, and then coming back and doing the one of the wires, and then again going off to do a different part of the build, gave enough time that just a few minutes for it to just cool down a little bit to dissipate that heat. But really, I don't think I got anywhere near the kind of threshold where the FET would take any kind of damage at all. So the UKNerfWar MOSFET kit is very cheap at £1 for the three components, but you do have to do the work yourself to actually solder it together. But using the diagram and following that meticulously, it doesn't take particularly long to do. It takes longer than just wiring up a flywheeler just with a bigger switch in the grip, but then you also don't have to fit a bigger switch in the grip if you don't want to. Now there seems to be a lot of disagreement on just exactly how much current this kind of micro switch can take, particularly as they're usually rated at a different voltage than what we're using them for, And there's also a difference between peak and continuous. And most of the Nerf stuff, we're far more interested in the peak than the continuous rating. Now, the UKNerfWar MOSFET is rated at 80 amps continuous or 170 amps burst, which is a lot. And if you're intending to use any single stage build, there's a very small number of motors that can actually break 170 amps between a pair, but they do exist. They're not particularly popular because of that high ampage rate, and you need a battery that can supply that as well. But then there's also quite a few motors where you can run 2 stages or even 3, like 6 motors in total, for less than 170 amps and get pretty good performance out of it. So this MOSFET kit certainly has a much higher capability than any of the physical switches that we've used before. Otherwise, I'm ED-SKaR, always have been. Thank you very much for watching, and if you're interested in the MOSFET kit itself, head to UKNerfWar.com, link in the description, for more information there.